industrial design, non-smooth B-spline curves. Almost every curve in the picture below is a uniform cubic B-spline. In fact, all of them are cubic B-spline except for two ellipses. But not all of them are smooth curves. Some have corners. For example, the curve used to represent the door of the car has a corner here. B-spline curves with corners can be obtained by repeating interior knots in the knot vector. The multiplicity of a knot is the number of times the knot appears in the knot vector. On the screen we see a B-spline curve composed of 6 cubic Bezier pieces. Each of them are traversed in 1 unit of time, so all these edges are 1, and the knot vector is a uniform knot vector. Here we have the basis functions that correspond to that B-spline function. If we make H2O to 0, the corresponding Bezier piece is going to be shorter and shorter until it disappears. In this situation, the B-spline curve is tangent to the segment D2, D3, and the knot vector has a knot with multiplicity 2, that is the knot 1. If we do the same with H3, the red piece is going to be shorter and shorter until it disappears. In this situation, the B-spline curve passes through the vertex D3, and the knot 1 has multiplicity 3. We can see that the curve has a corner at D3, and also the basis functions have a spike at 1, the knot that has multiplicity 3. Finally, if we make H4 to go to 0, the B-spline curve separates into two pieces. In this case, the first one corresponds to a Bezier curve because it only has 4 control vertices, and the second piece corresponds to a cubic B-spline curve with 2 Bezier components. In this case, the knot 1 has multiplicity 4. In a cubic B-spline, if an interior knot has multiplicity 2, the curve is tangent to one of the segments of its control polygon. Here 1 is repeated twice, has multiplicity 2, and the curve is tangent to the segment D2, D3. At the point of tangency, which is a junction of 2 Bezier pieces, the curve can fail to be C2, although it is C1. That is, the curve is smooth, but in general, its curvature need not to be continuous. In a cubic B-spline, if an interior knot has multiplicity 3, the curve passes through one of the vertices of its control polygon, and it is tangent to the segments of the control polygon adjacent to this vertex. In the picture, 1 has multiplicity 3, and the curve passes through D3, and is tangent to the segments D2, D3, D3, and D4. At such point, which is a junction of 2 Bezier pieces, the curve can have a corner. It fails to be C1, although it is C0. That is, the curve is not smooth, but it is continuous. In a cubic B-spline, if an interior knot has multiplicity 4, the curve consists of 2 separate pieces, and it is not continuous. Here 1 has multiplicity 4, and the curve has separated into 2 different pieces.